Imagine two stars locked in a deadly embrace. These stars are not just any ordinary celestial bodies, they are neutron stars, the remnants of massive stars that have exploded in supernovae. They are not ordinary stars radiating light and warmth. Instead, they are incredibly dense and compact, with a mass greater than that of our Sun but squeezed into a sphere only about 20 kilometers in diameter. These are stellar ghosts, remnants of once mighty suns. Their surfaces are covered in a crust of atomic nuclei, and beneath lies a sea of neutrons, packed so tightly that a sugar cube-sized amount would weigh 1 billion tons. We call them neutron stars. They are the densest and smallest stars known to exist, and their gravitational pull is so strong that it warps the space around them. Their gravity is so intense that a teaspoon of their material would weigh billions of tons on Earth. This immense gravity also means that they can pull in matter from their surroundings, creating powerful magnetic fields and emitting intense radiation. These cosmic dancers circle each other at incredible speeds, their orbital dance a prelude to a cataclysmic finale. As they spiral closer, they emit gravitational waves, ripples in the fabric of space-time that travel across the universe. Closer and closer they spiral, their immense gravity warping the very fabric of space-time. Finally, they collide. The collision is so violent that it can create a black hole, a region of space where gravity is so strong that not even light can escape. The result is a cosmic explosion of unimaginable power, a death scream that echoes across the universe. This explosion, known as a kilonova, releases more energy in a few seconds than our Sun will emit in its entire 10 billion-year lifetime. This is the story of neutron star collisions, events so powerful they can shake the universe and forge the elements that make up our very bodies. Gold, platinum, and other heavy elements are created in these cataclysmic events, seeding the cosmos with the building blocks of planets, stars, and life itself. Neutron stars are born from chaos. These enigmatic celestial objects are the remnants of massive stars that have undergone one of the most violent events in the universe. They are the remnants of massive stars, much larger than our own Sun, that have reached the end of their lives. These stars, often more than 8 times the mass of the Sun, live fast and die young, burning through their nuclear fuel at an astonishing rate. These stars burn brightly, fueled by nuclear fusion in their cores. This fusion process creates heavier elements, releasing tremendous amounts of energy that counteracts the force of gravity pulling the star inward, but eventually, their fuel runs out. When the nuclear reactions cease, the delicate balance between pressure and gravity is disrupted. The outward pressure from fusion can no longer hold back the immense gravity of the star's own mass. The core begins to collapse under its own weight, leading to a dramatic and violent end. The core collapses in on itself, triggering a catastrophic explosion known as a supernova. This explosion is so powerful that it can outshine an entire galaxy for a brief period. The outer layers of the star are blasted into space, seeding the cosmos with heavy elements. These elements, such as gold and uranium, are essential for the formation of planets and life as we know it. Left behind is a core, crushed to unimaginable densities. This remnant is incredibly small, yet it contains more mass than the Sun. This core, just a few miles across, is a neutron star. Despite its size, it has a mass about 1.4 times that of the Sun, making it one of the densest objects in the universe. It is composed almost entirely of neutrons, subatomic particles packed together in a state unlike anything found on Earth. The density is so extreme that a sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. Neutron stars are often born in binary systems, 2 stars orbiting a common center of mass. If the original stars were close enough, their neutron star remnants will be locked in a tight gravitational dance. Over millions of years, this dance becomes increasingly frantic. The neutron stars emit gravitational waves, ripples in the fabric of space-time as they spiral closer and closer. These waves carry away energy, causing the star's orbits to shrink. This orbital decay is relentless. It's a slow-motion train wreck with only one possible outcome, a cataclysmic collision. The moment of collision is a spectacle of unimaginable violence. The 2 neutron stars, each with more mass than our Sun, slam together at a significant fraction of the speed of light. The energy released is staggering, dwarfing the output of all the stars in our galaxy combined. This energy is released in a blinding flash of light, a burst of gamma rays that can be detected across billions of light years. The collision itself is over in a fraction of a second, but the echoes of this cosmic cataclysm linger for millennia, spreading out into the universe in the form of light, gravitational waves, and newly forged elements. The collision of neutron stars is a cosmic symphony, a concerto of light and gravity. Gravitational waves, predicted by Einstein over a century ago, are ripples in the fabric of space-time. These waves travel at the speed of light, carrying information about the most violent events in the universe. Neutron star collisions are one of the few events powerful enough to generate gravitational waves that we can detect on Earth. Gamma-ray bursts, on the other hand, are intense flashes of gamma rays, the most energetic form of light. These bursts are thought to be produced when jets of matter, traveling at nearly the speed of light, are blasted out from the poles of the colliding neutron stars. Section 6. Forging the universe's heaviest elements. The extreme conditions within a neutron star collision create a cosmic cauldron where heavy elements are forged. Gold, platinum, and uranium. These elements, so prized on Earth, are born in the fiery hearts of dying stars. When two neutron stars spiral towards each other and eventually collide, the energy released is beyond comprehension. This cataclysmic event generates temperatures and pressures so immense that atomic nuclei are forced together, creating new, heavier elements in a process known as rapid neutron capture, or the R process. The R process is responsible for the creation of approximately half of the elements heavier than iron in the universe. Imagine the sheer power required to forge these elements that we mine and use in our daily lives. Gold, for instance, is not just a symbol of wealth and beauty, it is a relic of a cosmic event that occurred billions of years ago. Platinum, used in everything from jewelry to catalytic converters, shares a similar origin story. Even uranium, which powers nuclear reactors, owes its existence to these stellar collisions. The intense heat and pressure of the collision provide the perfect environment for nuclear fusion to occur on a grand scale. This is not unlike the conditions found in the core of our own sun, but on a much more violent and energetic scale. The fusion process in these collisions is so powerful that it can create elements that are otherwise impossible to form under normal stellar conditions. Neutrons are captured by atomic nuclei, creating heavier and heavier elements. This process continues until the newly formed elements are ejected into space by the force of the collision. These elements then mix with the interstellar medium, the vast expanse of gas and dust that exists between stars. These newly forged elements are then blasted out into space, enriching the surrounding interstellar medium. Over time, this enriched material will coalesce to form new stars and planetary systems. The cycle of stellar birth, death, and rebirth ensures that the universe is constantly evolving and that the elements necessary for life are continually replenished. Over billions of years, this enriched material will form new stars, planets, and even life. The very atoms in our bodies were once part of ancient stars that lived and died long before our solar system was born. This cosmic recycling process is a testament to the interconnectedness of all things in the universe. The very gold in your jewelry is a testament to the power of neutron star collisions, a reminder that we are all made of star stuff. Every time you look at a piece of gold, remember that it was forged in the heart of a dying star, a relic of a cosmic event that shaped the universe as we know it. Section 7. Windows to the early universe. Neutron star collisions are not just destructive events, they are also invaluable tools for astronomers, providing insights into the fundamental laws of physics and the conditions in the early universe. By studying the gravitational waves and light emitted during these collisions, we can learn about the properties of matter at extreme densities and temperatures. These observations can help us test our understanding of gravity and the nature of space-time itself. Furthermore, because neutron star collisions are so bright, we can detect them across vast cosmic distances. This allows us to study the properties of galaxies and the intergalactic medium billions of years in the past, giving us a glimpse into the early universe. Section 8. The future of neutron star astronomy. The study of neutron star collisions is still in its infancy. However, with the advent of new and more sensitive telescopes, both on Earth and in space, we are entering a golden age of gravitational wave astronomy. These instruments will allow us to detect even more of these cosmic cataclysms, providing us with a wealth of data to unravel the mysteries of these extreme objects. As we continue to explore the universe, we are sure to find even more surprises. Neutron star collisions are a powerful reminder of the vastness and wonder of the cosmos, and the incredible forces that shape our universe. Section 9. A universe of wonders awaits. The universe is a vast and mysterious place, full of wonders beyond our wildest imaginations. Neutron star collisions, these cataclysmic events that shake the very fabric of space-time, are just one example of the incredible forces at play in the cosmos. As we continue to explore the universe, we are sure to find even more awe-inspiring phenomena that challenge our understanding of physics and broaden our horizons. The journey of discovery has just begun,